Okay, the first three chapters or so of the textbook is largely review of general chemistry or your AP chemistry course, although there are some new ideas sprinkled in there. Unfortunately, it'll seem like a hodgepodge of various topics just sort of strung together, but they're worth going over. This way, we're all on the same page. So we'll cover them at a somewhat quick pace. The next several sections of Chapter 1 are dedicated to electronic structure and bonding. Okay, now both the atoms and how they're bonded together within a molecule is important in defining the structure and the properties of that molecule. And so a simple example is that of dimethyl ether and ethanol. Both of these compounds have the molecular formula C2H6O, but they have very different properties. Okay, for example, dimethyl ether has a boiling point of minus 24 degrees Celsius, whereas ethanol boils at about 78 degrees Celsius. Okay, so the different bonding in these two molecules can manifest in greater than 100 degrees difference in the boiling point. Additionally, dimethyl ether is actually a weak base, where ethanol is a weak acid. Okay, now this idea of molecules having the same molecular formula but different arrangements of atoms and bonds is known as isomerism. And so dimethyl ether and ethanol are referred to as isomers. And so isomers have the same molecular formula, but different arrangement of atoms. Okay, so dimethyl ether and ethanol are a specific type of isomer known as a constitutional isomer. And what this means is that the atoms are bonded together differently. Okay, so they have different connectivities. All right, one other thing that needs to become sort of second nature to us as we're going through the course is the idea of valency of the main atoms that we're going to use in organic chemistry. So the valency is the number of bonds an atom usually forms. Okay, so for carbon, the valency is 4. So carbon likes to form 4 bonds. Hydrogen forms 1 bond, nitrogen 3, oxygen 2, and the halogens form 1 bond. Okay, so let me point out, X here is often used as an abbreviation for a halogen, okay, without specifying the specific halogen. Sometimes I'll deviate from this and use X as just a generic organic group, but normally we'll use X to indicate an unspecified halogen. Okay, so these valency numbers, if we deviate from them, this usually means that the molecule has to have a charge, or that particular atom needs to have a formal charge. And we're going to talk about formal charge in a few moments.